Welcome to Video Quiz Chapter 8. This is Business 100. Chapter 8 is Managing Service and Manufacturing Operations. Okay, we aren't going to go over all of the slides, but we'll go over a lot of them for this particular subject. And I'm not putting my video up here because mainly we want to concentrate on the material. There's no need for me to be looking at you or you looking at me or whatever. So, learning objectives: define operations management and differentiate between operations and manufacturing. We'll talk briefly about that. Explain how operations management differs in manufacturing and service firms. Describe the elements involved in planning and designing an operations system. Specify some techniques managers may use to manage the logistics of transforming inputs into finished products. Assess the importance of quality in operations management. So those are the things that we're going to be looking at. Now, operations management, the definition here, is the development and administration of the activities involved in transforming resources into goods and services. Okay. Historically, operations management has been called production or manufacturing, limiting it to physical goods. However, we have changed from production to operations, and this views functions as a whole and recognizes services and ideas. Okay, businesses aren't always just in the business of producing services. Oftentimes, a business may produce, producing goods, physical goods. Instead, they may be providing services or ideas even. Now, historically, operations management has been called production or manufacturing primarily because of the view that it was limited to the manufacture of physical goods. Its focus was on methods and techniques required to operate a factory efficiently. So we have this older version of operations management called production or manufacturing, and these were ideas that were used to produce methods and techniques to operate a factory. The change from production to operations recognizes the increasing importance of organizations that provide services and ideas. Additionally, the term operations represents an interest in viewing the operations function as a whole rather than simply as an analysis of inputs and outputs. Okay. Today, operations management includes a wide range of organizational activities and situations outside of manufacturing, such as healthcare, food service, banking, entertainment, education, transportation, and charity. To give you an example of this, we'll talk a little bit more about it later, is McDonald's, fast food, is really an application of production management techniques to or operations management techniques to the production of hamburgers. Okay. OM activities can involve manufacturing or production, somebody who makes a tangible product. Operations makes tangible and intangible products. So that's the difference here, okay, between operations and manufacturing or production. Operations includes both intangible objects like services and ideas. Manufacturing and production involve only tangible physical products. The transformation process. At the heart of operations management is the transformation process through which inputs, resources such as land, labor, money, materials, and energy, are converted into outputs. These are the goods and services that we sell to our customers. The transportation process combines inputs in predetermined ways using different equipment, administrative procedures, and technology to create a product. To ensure that this process generates quality products efficiently, Operations managers control the process by taking measurements, or what we call feedback, at various points in the transformation process and comparing them to previously established standards. They may then take corrective action for any deviation from these standards. So to make a simple example, one aspect of this transformation process might be taking rubber and steel belts and feeding them into a tire making machine where these are combined to produce a tire. This transformation process, the inputs are the steel belts, the rubber, and the output is the tire. Operations managers may take measurements, for example, by counting the number of tires a particular operator produces every hour and comparing them to an established standard, say 20 tires an hour. If a worker is producing fewer than 20 tires an hour, the management may step in and take corrective action. Find out why we're producing less than 20 tires an hour. Is it a problem with the equipment? Is it operator error or problems with the operator? What exactly is causing this deviation from the standard? Now, those inputs are the resources such as labor, money, materials, and energy that are converted into outputs. The outputs are the goods and services and ideas that result from the conversion of inputs. Operations, the activities and processes used in making both tangible and intangible products. We've talked about that before. So here is a typical process here. We may have inputs, land, labor, capital, raw materials, time, information, energy, that gets converted through a transformation or conversion process. The procedures, equipment, facilities, technology, knowledge here in this factory, to the production of outputs, goods, services, ideas. Okay, there's furniture here, a plane, legal services here. We might be producing ideas. Control standards provide feedback from, in this case, the consumer here. Here we're talking about ever-evolving distribution systems. Okay. Amazon has 70 distribution centers. They're optimized for space, retrieval, and delivery. Amazon Prime uses 2-day or same-day delivery, movie streamings, and online access to books. And they have plans to use drones where they can get you a good or service within half an hour. Now, one of the things you have to be aware of is that when we talk about, in this case, the drones, it is currently illegal in the United States to use unmanned drones. Okay, so you can see they're testing that in Great Britain. Okay. To remain competitive, Amazon distribution strategies are constantly evolving towards even faster delivery. We got Amazon Prime uses 2-day or same-day delivery. We've got streaming, online access. Those are all ways in which Amazon has tried to get goods and services faster to their customers. Okay. Here we have inputs, outputs, and transformation process in the manufacture of oak furniture. Here you've got oak trees, labor, information, knowledge, stain or varnish, or router, saw, warehouse space, time. The transformation is cutting or sawing, routing the wood, measuring it, assembling the oak furniture, staining, varnishing, and storing that until it can be sold to a customer. And that produces your output of oak furniture. Operations management in service businesses. Transformation processes occur in all organizations regardless of what they produce or their objective. significant customer contact component to most services. When we are involved in the performing of services, we have to realize that we're going to be in contact a lot more with the customers. Examples of that would be retailing, restaurants. Okay. You strive to provide standardized processes. We'll talk about standardization later, but that is an effort to produce a known product to consumers that are all produced in basically the same way. Technology offers an interface that creates automatic and structured response. Output is generally intangible and even perishable. Few services can be saved, stored, resold, or returned. Examples of this are airplane seats. Okay, a plane leaves at 6 o'clock from Birmingham, gets into New York at 9:30 a.m. We can't save those seats, okay, or at least not very easily. So operations management with service businesses can often be different in these ways from what they would be in a production business or manufacturing. Okay. Oops, my fault. Now, the nature and consumption of output. Services require more customer contact and happen at the point of consumption. Okay. First, manufacturers and providers differ in the nature and consumption of their output. For example, the term manufacturer implies a firm that makes tangible products. A service provider, on the other hand, provides more intangible outputs such as postal delivery for the U.S. Post Service or a business stay at a Westin hotel. The very nature of the service provider's product requires a higher degree of customer contact. Moreover, the actual performance of the service typically occurs at the point of consumption. At the Westin, business travelers may be very pleased with the heavenly bed and shower systems, which are both proprietary and luxury amenities, or customers may like getting points through their reward membership or upgrades if they stay with a firm like Starwood Preferred Guest. Automakers, on the other hand, can separate the production of a car from its actual use, but the service dimension requires closer contact with the customer. Manufacturing then can occur in an isolated environment away from the customer. However, service providers, because of their need for customer contact, are often more limited than manufacturers in selecting work methods, assigning jobs, scheduling work, and exercising control over options. Now, this next example we're going to talk about here with the nature and consumption of output deals with a company called Zappos, which is a shoemaker. And they adopted an online scheduling platform called Open Market to schedule its worker hours. Before, the process was complicated and involves workers having to write their schedule preferences on sheets of paper. This new scheduling platform uses surge-based pricing that provides higher compensation to workers who take shifts in periods of high demand. The quality of the service experience is often controlled by a service contact employee. However, some hospitals are studying the manufacturing process and quality control mechanisms applied in the automotive industry in an effort to improve service quality. By analyzing work processes to find unnecessary steps to eliminate and using teams to identify and address problems as soon as they occur, these hospitals are slashing patient wait times, decreasing inventories of wheelchairs, readying operating rooms sooner, and generally moving patients through their hospital visit more quickly with fewer errors and at a lower cost. The next thing we're going to talk about is the uniformity of inputs. Services are more customized to each user. A second way to classify differences between manufacturing and service providers has to do with the uniformity of inputs. Manufacturers typically have more control over the amount of variability of the resources they use than do service providers. For example, each customer calling Fidelity Investments is likely to require different services due to differing needs, whereas many of the tasks required to manufacture a Ford Focus are the same across each unit of output. Consequently, the products of service organizations tend to be more customized than those of their manufacturing counterparts. Okay. So here for manufacturing, the uniformity of inputs is more likely relative to service manufacturers. And when it comes to the university of output, again, products or production, typically the output is going to be more uniform rather than for the services. Okay. Services are oftentimes more labor intensive, as we said, more contact with customers, fewer machines or capital goods are available to be used. And finally, the measurement of productivity. Intangibility makes measurement more difficult for operations management in the service businesses. I can talk about that directly in the field that I am, education. The state of Alabama has tried many times to measure the productivity of colleges and schools. Federal government measures, such as for high schools, No Child Left Behind, or these types of things, have all been attempts to try and measure the amount of educating that goes on in the schools. Each and every time they try to measure something, teachers, professors change to fit those standards. One of the byproducts of No Child Left Behind is that they've started to use pass rates as a metric to measure productivity of teachers in the high schools and colleges. Well, if you're going to pay people based on those metrics, people are going to pass more students. There are two ways to pass more students. One is you could work harder, focus on students who aren't passing, and spend more time and effort in identifying and helping those students with material. Or you can simply lower your standards and grade inflate. And of course, this has resulted in large amounts of grade inflation. In fact, many school districts, it's very difficult to fail a student. They basically have to have had serious behavioral problems or attendance problems for them not to be passed. As long as they show up and do a small amount of work, then they're going to be passed. So oftentimes it's more difficult to measure productivity in a service environment. We will pause here and have a quick short quiz and then come back. We'll start the next slide. Planning and design operation systems. Here, planning the product. Operations operations planning involves making the following decisions. One is, what will we produce? Who are our customers? What processes will we use? And where will we make our products? Planning the product. So here we're dealing with what product will we make. Marketing research helps determine product and features that customers want. Gauge demand, set price. Once management has decided what to produce, they must then plan on how to produce that product. Operations managers plan for resources needed to complete that transformation process. Now, when we talk about designing operations processes, one of the things we look at is standardization. Most firms that manufacture product in large quantities for many consumers have found that they can make it cheaper and faster by standardizing designs. Standardization is making identical, interchangeable components or even complete products. With standardization, a customer may not get exactly what he or she wants, but the product generally costs less than a custom designed product. Okay. Modular design is another aspect of the operations product. This involves building an item in self-contained units or modules that can be combined or interchanged to create different products. Many automobile manufacturers use modular design in the production process. Manufactured homes are built on a modular design and often cost about 1/4 the cost of a conventionally built home. Okay. So here, standardization used for large quantities for many consumers. Modular design allows for quick repair, but it is costly. Modular design reduces the cost. Many of these modular components are produced as an integrated unit. The failure of any portion of a modular component usually involves replacing the whole component. Customization is making products to meet a particular customer's needs or wants. Products produced in this way are generally unique. Such products include repair services, photocopy services, custom artwork, jewelry, and furniture, as well as large-scale products such as bridges, ships, and computer software. The jewelry aspect of things. I was a banker in Scottsdale, Arizona, and many of my customers had jewelry shops where they made high-end jewelry. And they would make jewelry designed specifically for each wearer. Now, one of the problems with customization is that it can increase the amount of time that it takes to produce goods or services. It better suits the customer's needs, which is a positive, but oftentimes it can cost more because you cannot have the benefits of standardization there. Planning capacity, unit of measurement could be worker, machine, department, branch, or an entire unit. The term capacity basically refers to the maximum load that an organizational unit can carry or operate. The unit of measurement again may be worker, machine, department, branch, or even an entire plant. Maximum capacity can be stated in terms of the inputs or outputs provided. So for an example, electric power plant might state plant capacity in terms of the maximum number of kilowatt hours that can be produced without causing a power outage. A restaurant might state the maximum capacity in terms of the number of consumers. Now, planning capacity is very important. Efficiently planning the organization's capacity needs is an important process for the operations manager. Capacity levels that fall short can result in unmet demand and consequently lost customers and a reduction in profits. Capacity levels that are too high are too high can result in higher operating costs due to unused and often expensive resources. To avoid such situations, organizations must accurately forecast demand and then plan capacity based on these forecasts. Sorry about that. I've got a little bit of an allergy or something going, and it was making me cough here. Planning facilities. Okay. Here, once a company knows what process it will use to create its products, it can then design and build an appropriate facility in which to make them. Many products are manufactured in factories, but others are produced in stores, at home, or where the product ultimately will be used. Companies must decide where to locate their operations facilities, what layout is best for producing their particular product, and even what technology to apply to them. Again, sorry about that. The first thing we have to decide is where to locate it. This is significant due to the high cost involved and complex because it involves the evaluation of many factors, some of which cannot. Okay. So there's many complex factors involved here, some of which cannot be measured with precision. One is proximity to market. Some businesses, it's very important that they're close to their market. For example, something we'll talk about later, just-in-time inventory systems. There, if you're the supplier, oftentimes you want to locate close to, or excuse me, if you're the person being supplied, you want to locate close to your supplier. The availability of raw materials, transportation, power, and labor. Here in Gadsden, in the Gadsden area, we are very blessed with transportation. Quite a bit of transportation. We have railway hubs nearby, and we have the I-59 and the I-20 intersect here. This is good, especially for the automobile producers, because they can ship their cars up the 59 all the way up to the Midwest. They can ship them all the way down to this deep south in Louisiana and in New Orleans, which is a big port. And they can ship those goods cross country on the I-20 from West Coast to East Coast. So that is a factor that many people planning facilities would look to for a facility location is, hey, they've got great transportation there. Labor, are labor costs high or low? Power, do you have the power necessary to run the plant, and are raw materials available? Climatic influences and community characteristics, taxes and inducements. These are all things that someone would look for when planning a facility location. The next thing we have is the facility layout. This is arranging the physical layout of a facility, and it is a complex and technical task. Some industrial architects specialize in the design and layout of certain types of businesses, and there are three basic layouts. The first one is the fixed position layout. Here, a company using a fixed position layout brings all resources required to create the product to a central location. The product, perhaps an office building, house, hydroelectric plant, or bridge, does not move. A company using a fixed position layout may be called a project organization because it is typically involved in large, complex structures, projects such as construction or exploration. Another form of facility layout is the process layout. Firms that use a process layout organize the transformation process into departments that group related processes. A metal fabrication plant, for example, may have a cutting department, a drilling department, and a polishing department. Hospitals are perfect examples of this. They may have a cardiology, urgent care, neurology, obstetrics, and gynecology units, and so on. These types of organizations are sometimes called intermittent organizations. These are organizations that deal with products of a lesser magnitude than do project organizations. Their products are not necessarily unique, but possess a significant number of differences. The final type of facility layout we have here is the product layout. This is a layout requiring that production be broken down into relatively simple tasks assigned to workers who are usually positioned along an assembly line. The types of firms that typically use the product layout are continuous manufacturing organizations, companies that use continuously running assembly lines, creating products with many similar characteristics. An example of this might be Honda or Goodyear here in the Gadsden area. Technology. Developments in computers and robotics have strongly influenced operations of many businesses. Now, every business has a basic underlying technology that dictates the nature of its transformation process. You can think of technology sort of as a recipe. We have these inputs, water, flour, sugar, yeast, salt, that go in your time and oven time that go in to producing an output, which might be a loaf of bread. The technology is the list of the inputs we need and how to combine them to produce the bread. Now, computer-assisted design computers were introduced in the late 1950s by IBM. The operations function makes great use of computers in all phases of the transformation process. One example of this is computer-assisted design, or CAD. This helps engineers design components, products, and processes on the computer instead of on paper. CAD software is used to develop a 3D image. Then the CAD file is sent to the printer. The printer is able to use layers of liquid, powder, paper, or metal to construct a 3D model. Okay. So that is CAD. Computer-assisted manufacturing goes a step further, employing specialized computer systems to actually guide and control the transformation process. Such systems can monitor the transformation process, gather information about the equipment used to produce the products, and about the product itself as it goes from one stage of the transformation process to the next. The computer provides information to an operator who may, if necessary, take corrective action. In some highly automated system, the computer itself can take corrective action. So here, we're using the computer to come up with a 3D model. With computer-assisted manufacturing, the computer actually guides and controls the production process. Using flexible manufacturing, computers can direct machinery to adapt to different versions of similar operations. For example, with instructions from a computer, one machine can be programmed to carry out its function for several different versions of an engine without shutting down the production line for refitting. One interesting example, something that relates back to Amazon, is the use of drones in business operations would vastly change the technology landscape. Drones refer to unmanned aerial vehicles and have long been used in military operations. Amazon is pursuing methods to use drones for package delivery. Amazon has secured a patent to allow it to drop packages delivered by its fleet of drones by parachute. However, currently the use of automated drones without direct supervision is illegal in the United States. Another thing here is robots. Robots are becoming extremely useful in the transformation process. They're particularly important in industries such as nuclear power, hazardous waste disposal, ocean research, and space construction and management, in which human lives would otherwise be at risk. Robots are used in numerous applications by companies around the world. Many assembly operations, cars, electronics, metal products, plastics, chemicals, and numerous other products depend on industrial robots. The economic impact of robots was quantified by two economists who found that for every robot per 1,000 employees, up to 6 employees lost their jobs, and wages fell by 0.75%. In the next 15 years, PwC projects that 38% of the jobs in the United States are at risk of being lost to robots and artificial intelligence. This is something that's very important. I think that in your lifetimes, robots are going to be replacing a lot of jobs, especially in construction, manufacturing processes, and you have to be able to do things that robots can't do. That means repairing the robots, telling robots what to do, figuring out how to use robots in production processes, making robots. These are things, along with, say, accounting or entrepreneurship. These are types of activities that robots are not able to do, nor are computers. I think there's going to be a big spread in income between those people who do things that robots can't do and the rest of the population, which will be doing things that aren't important or valuable enough to use robots on, such as walking dogs or talking to old people or driving them around to their doctor's appointments. Okay? So you want to make sure that your future doesn't rest on continuing to do something that a robot can do, because in the next 20 to 30 years, especially, those jobs are going to go away. This is going to allow for increased productivity. We will produce more goods and services, which will lead to higher living standards for people. However, there's going to be a dramatic increase in the living standards of people who do things that robots can't do, or computers, and not so great of an increase in living standards, relatively speaking, for those who do things that robots are too valuable for. So consider that when you start planning out your future. That's the end of this lecture. We'll have a short quiz, and good luck.